go, doing some chain rule to save that GPA. All right, as you can see in the first example, I've got a square root function on the outside and a function on the inside. So this is definitely alerting me to the chain rule. But after weeks of prepping and watching so many videos, I know that I can do it. So I'm going to rewrite this function first as my first step. So I've got 21. The square root function is the same thing as taking anything to the 1/2 power. So I'm going to rewrite this as 16x minus 3x to the 5th to the 1/2 power. So those two things in red and blue are equivalent. And now I'm going to apply the chain rule. So the 21 out here is just like what we've been doing. So like if I had y is 3x squared, the derivative, I'm going to use the power rule, so that 2 is going to come down, and I'm going to have 3 times 2x. So my derivative, that 3 just kind of comes along for the ride. My derivative is 6x. So that 21 is just going to come along for the ride. So my derivative, I'm going to leave that 21 out front, and I'm going to use the power rule to the function on the outside, the square root function. So the 1/2 is going to come down, and then I'm going to take 1 degree less from 1/2, which will become my new exponent, will become a negative 1/2. So power rule, anything x to the 1/2, if I take the derivative of that, I simply get 1/2 x to the negative 1/2 power. So coming over to my nastier function here, I'm going to have 21 times 1/2. The inside just stays as is to the negative 1/2 power. So again, just like thinking about the chain rule, the derivative of a function, of a composite of functions, the derivative of the outside, inside stays as is, times the derivative of the inside function. So this g of x, I'm doing g prime of x, a product, I'm going to multiply by the derivative of the inside. So I'm going to take the derivative of the inside, which will just give me 16 minus, now I'm going to apply the power rule, the 5 is going to come down, 15x to the 4th power. And just stop there. Yeah. All right, let's do another example. All right, here. Now, just like in the previous example when I had a square root and I rewrote that square root to the 1/2 power, I don't like square roots and I don't like fractions. So I'm going to rewrite this equation, or this 15 over 3x minus 20x to the 4th to the 9th power. I'm going to rewrite this as just a product using negative exponents instead of a quotient. So y will be 15 times 3x minus 20x to the 4th to the negative 9th power. Yeah. So some of you might find that funny. I didn't do anything crazy. I just rewrote it. Now I'm going to take the derivative. So my y prime, again, the 15 just comes along for the ride, and I'm going to do my power rule. So if I'm just taking the derivative of something to the negative 9th power, it becomes negative 9x to the negative 9 minus 1, go 1 degree less, negative 10. But since this is a composite of functions, I just don't have an x here. I've got some sort of function inside of a function. I'm going to apply the chain rule and multiply by the derivative of what was inside. So negative 9 comes down, 3x minus 20x to the 4th. The g of x, the inside function, just kind of goes along for the ride as well, to the negative 10th power times the derivative of what's inside. 3 minus, the 4 comes down, 80x to the 3rd power. Chain rule. No problem. One more example. A square root in the denominator. But I'm not worried. Those last two examples. Hey, stop screaming. You got this. Let's rewrite it. A square root is the same thing as raising to the 1/2 power. Since this is a fraction and I don't like fractions, let's make it to the negative 1/2 power. Boom, rewriting. Now it looks just like the other examples. I can do this. This is a composite. The outside function is a negative 1/2, so let's just practice that for a second. X to the negative 1/2, negative 1/2, x, negative 1/2 minus 1, negative 3/2 power. 7's going to come along for the ride. I'm going to leave the inside as is, but then take the derivative of that inside function. So here we go, calculorians. 7 times a negative 1/2, because I brought the power rule, the negative 1/2 came down. Inside function stays as is, 19x plus 8x to the 4th to the negative 3/2 power times the derivative of the inside function. 19 plus 32x cubed. Excellent work. Hey, I hope you liked this video. Make sure you subscribe, and when you're done, smash that like button. Boom!